Good morning guys. So today we will take our next lecture regarding the assembly of stiffness matrix for isoparametric element. Okay, so as we know that how to assemble the stiffness matrices for our previously we have seen our one-dimensional, two-dimensional elements. So here we are going to see how to assemble the stiffness matrix for isoparametric element. Okay, so as we know that in previous lecture we have studied our isoparametric element. So isoparametric element, it means what? Okay, we need to overcome, or we need to, if we need to increase the accuracy of the problem or accuracy of the results, then we need to use the isoparametric elements if there are irregular geometries. Okay, so instead of using triangular and rectangular elements, we need to use the isoparametric element for increasing the accuracy of the results. Okay, so for this purpose we are going to use our isoparametric element. Okay, so to map the irregular geometries, we need to use the isoparametric element. Okay, so now in this lecture we will see, as we have already studied, how to coordinate transformation, how to transform the coordinates from your natural coordinate systems to Cartesian or global coordinate system. It means, as we know that for natural coordinate systems the coordinates are zeta and theta, and how to transform these coordinates, natural coordinates, to Cartesian coordinates, means x and y. Similarly, how to get this zeta and theta if we know the x and y values. Okay, so we have studied, or we have actually taken some examples related to this coordinate transformation. Okay, now we will see, we will obtain the stiffness matrix for this isoparametric element in this lecture. So as we know that, suppose if we need, if you are asked to find out the strain at any point in this isoparametric element. Okay, so as we know that, basically we know the strain value is given as epsilon x, as because this geometry is a two-dimensional geometry, so we need to consider three types of strains. So epsilon x, epsilon y, it means strain in y direction, and gamma x1 means shear strain. So as we know that the basic formula for to find out the strain in x direction, it is given by dou u by dou x. Strain in y direction, it is given by dou v by dou y, and the shear strain, it is given by formula dou u by dou y plus dou v by dou x. Okay, so if we need to find out the strains in the isoparametric element, then we need to calculate dou u by dou x, dou v by dou y, and dou u by dou y plus dou v by dou x. By determining these values, you will get epsilon x, epsilon y, epsilon gamma x. Okay, so it means what? We need dou u by dou x and dou v by dou y. Similarly, dou u by dou y and dou v by dou x. Okay, so to get the strains in x, y, and x direction, y direction, and shear strain. Okay, so we need these values. It means we need to take derivative of this displacement u. Okay, so this is the first thing. So as we know that, so now we will start this procedure to find out the strains in the strains in isoparametric element, or strain at any point in the isoparametric element. Okay, so as we know that the shape functions for this natural coordinate system, as we have already studied this concept of shape functions n1, n2, n3, and n4, because n1 is nothing but 1 minus eta divided by 4. Similarly, n2 is 1 plus zeta 1 minus eta divided by 4, and similarly you will get n3 and n4. n3 what will become 1 plus zeta by 4, and n4 is 1 minus zeta 1 plus zeta by 4. So here you will see n1, it is function of zeta and eta. So it means what? N shape function Ni, this is the function of zeta and eta. Now from these shape functions you will get Cartesian coordinates. Now Cartesian coordinates, what is the formula? So basic formula we know that to find out the Cartesian coordinates, x is equal to what? Summation of Ni xi. It is nothing but N1 x1 plus N2 x2 plus N3 x3 plus N4 x4. And similarly y you can write summation of Ni yi is equal to what? N1 y1 plus N2 y2 plus N3 y3 plus N4 y4. So in this way you will get this Cartesian or global coordinates from this natural coordinate system. Okay, because this N1 it is function of what? This N1 is function of zeta and eta. Similarly N2, N3 and 4, these are the functions of zeta and eta. Now second thing is what? So these are the Cartesian coordinates. As we know that the displacements u and v, these are the displacements at any point in the isoparametric element. Now these displacements we can write in this same fashion. We can write this displacement because by using this same shape function from the parent element, we can write displacement for the isoparametric element. So how to write these displacements for the isoparametric element? Same way we can write as u is equal to u1 n1 plus u2 n2 plus u3 n3 plus u4 n. Okay, so similar to this Cartesian coordinates, we can write our displacements. U is equal to u1 n1 plus u2 n2 plus u3 n3 plus u4 n1. Similarly, displacement in y direction can be written as v1 n1 plus v2 n2 plus v3 n3 plus v4 n. Okay, so here we have written the displacements u and v. As first we have written x and y, then we have written u and v by taking the reference of this x and y. So here from this we conclude that, as we know that u is the function of x and y. Okay, so this displacement, it is the function of these coordinates x and y, and also we know that x and y, or you can say that u and v, this is function of x and y, and x and y, this is function of what? Shape function n, but n is function of what? X and y, this is function of this ni, but ni is function of what? Over zeta and eta. Okay, so finally you will get, one second. Okay, so from these shape functions ni you will get x and y. From this x and y you will get u. It means what? Your u comma v, this is function of x and y, and this x and y, this is function of your zeta and eta. So ultimately what? Finally this u and v is function of zeta and eta. Okay, so it means what? We need to take the partial differentiation, because to find out epsilon x, epsilon y and gamma xy, we need derivative of this u as well as derivative of this v. Okay, so if we need to derive this u and v with respect to x and y as well as with respect to zeta and eta, we need to take the partial differentiation of this u and v with respect to zeta zeta and eta. So we can write the partial differentiation. One second. So as we know that u and v is the function of x and y, and x and y, these are the functions of zeta and eta. So we need to take, if we need the derivative of u and v, we need to take the partial differentiation with respect to zeta and eta. So what will be the partial differentiation? So dou by dou zeta, dou u comma v by dou zeta, similarly dou u comma v by dou eta. So we can write as dou u by dou x, dou u comma v by dou x into dou x by dou zeta plus dou u comma v by dou y into dou y by dou z. Similarly, with respect to eta, here we are writing the partial differentiation. Partial differentiation means differentiating with respect to first variable, keeping second variable constant, and then for second term, keeping first variable constant and differentiating second variable with respect to second variable. So similarly here we can write with respect to eta dou u by dou v by dou x into dou x by dou eta plus dou u by dou v into dou y into dou y by dou eta. So in this way you can write the partial differentiation of this system. So in general we can write the partial differentiation with respect to zeta and eta as, so if we remove this u and v sign, so we can write dou by, so here only I will simplify the step. So here if we remove this u and v for general partial differentiation, dou by dou zeta will become dou by dou zeta is equal to dou by dou x into dou x by dou zeta, dou by dou y into dou y by dou zeta. Similarly, here if we remove u and v for general purpose, it will become dou by dou x into dou x by dou eta. Similarly, dou by dou y into dou y by dou eta. So generally, finally we can write this as dou by dou zeta is equal to dou x by dou zeta into dou by dou x plus dou y by dou zeta into dou by dou y. And similarly, dou by dou eta will become dou x by dou eta, dou x by dou eta into dou by dou x plus dou y by dou eta into dou by dou y. Okay, so for general purpose we are writing only dou by dou zeta and dou by dou eta. So in this way you will get dou by dou zeta and dou by dou eta by using partial differentiation. So okay, so we can write, now we can write this equation. Okay, here we can write these two equations in matrix form now. So in matrix form, what will become dou by dou zeta, this will become first vector, and dou by dou eta. Okay, one second. Dou by dou zeta, here we will write dou by dou zeta, and second thing is dou by dou eta. So this will become equal to this matrix. Okay, so here dou by dou x is the common term, dou by dou y and dou by dou y it is also common term. So we can write dou x by dou zeta, dou x by dou zeta, dou y by dou x by dou zeta, dou y by dou zeta, dou x by dou eta and dou y by dou eta and into this vector. What will be the vector? Dou x by dou x and dou by dou y. Dou by dou x and dou by dou y. This is the second vector. Okay. So if we multiply this row to this column, you will get this equation. So dou by dou zeta is equal to dou x by dou zeta into dou by dou x. Dou x by dou zeta into dou by dou x plus dou y by dou zeta into dou by dou y. Dou y by dou zeta into dou by dou y. Okay. So in this way, you will get the matrix equation from these two equations. Okay. So here we can write this as dou by dou zeta and dou by dou eta is equal to J matrix into this vector dou by dou x, dou by dou y. Okay. But this J vector is nothing but your Jacobian. This term actually we have covered in your third unit. So this J, it is nothing but Jacobian matrix. Okay. So this matrix is known as Jacobian matrix. Okay. And for 6 to 8 marks, some examples will be asked to find out the Jacobian matrix in this fourth unit only. For your examination, some examples will be asked on this Jacobian matrix for 6 to 8 marks. Okay, I am going to take some examples related to this Jacobian matrix in next lecture. Okay, so first we will try to find out our dou u by dou x and dou u by dou y. Okay, so here J is nothing but your Jacobian matrix. Instead of this matrix, here I am writing this J. Okay, so J is nothing but your Jacobian matrix. How to solve this Jacobian matrix or how to get this Jacobian matrix terms, I will solve some examples in your next lecture. Okay, so just I will simply some how to get these terms. I will explain for one term only and we will proceed. Okay, so this is your Jacobian matrix. Okay, this is your Jacobian matrix. So J is equal to this matrix. Now this term here, I will put this term here only and we will solve remaining examples. So dou by dou zeta, dou by dou eta is equal to J times dou by dou x, dou by dou y. Okay, our main motive is what? To find out this vector only, because dou u by dou x and dou v by dou y, these terms you will get from this vector only. Okay, so main target is what? We need to get this dou by dou x and dou by dou y vector, because as we know that for epsilon x is equal to your dou u by dou x and epsilon y is equal to your dou v by dou y. But for this gamma x1, we need dou u by dou y plus dou v by dou x. It means we need dou u by dou x, dou u by dou y. Similarly, we need dou v by dou x as well as dou v by dou y. So these four terms we need to find out epsilon x, epsilon y and gamma x. Okay, and these four terms we will get from this vector only. Okay, so I will just put this equation here only and I will explain now first term, how to determine the first term of the Jacobian matrix. For your numerical purpose, here I will explain only how to determine the dou x by dou zeta. In similar way, you can determine dou y by dou zeta, dou x by dou eta and dou y by dou eta. Okay, so here we will see this first term only. Okay, so let us say suppose this is equation 1, because we need this equation for our further treatment. Okay, so here, so how to determine this dou x by dou zeta? Dou x by dou zeta is 1. If some examples are asked to find out Jacobian matrix terms, to find out Jacobian matrix terms, to find out these 4 terms. So here I am explaining your first term to determine dou x by dou zeta. So as we know that x is what your x is summation of ni xi. So summation of ni xi is nothing but n1 x1 plus n2 x2 plus n3 x3 plus n4 x4. Okay. So dou x by dou zeta, how to determine then dou x by dou zeta? As we know that this n1, n2, n3 and n4, these are the functions of zeta and eta. Okay. So if we write in terms of zeta and eta, these n1, n2, n3 and 4 terms, then we can easily determine dou x by dou zeta. So how? So x is equal to, in terms of zeta and eta, n1 is what? 1 minus zeta, 1 minus eta divided by 4 times x1 plus 1 minus zeta, sorry, here a second, 1 plus zeta, 1 minus eta divided by 4 times x2 plus 1 plus zeta, 1 plus eta divided by 4, because instead of n3 I am writing these terms into x plus 1 minus zeta, 1 plus eta divided by 4 times x. Now it is easy to find out dou x by dou zeta. Means take derivative of this first term with respect to zeta, second term with respect to zeta, third term with respect to zeta, fourth term with respect to zeta. So in this way you can get, or you can determine the dou x by dou zeta. Similarly, you can determine dou y by dou zeta. Here the terms will be replaced, instead of x1, x2, x3 and x4, the terms will be replaced as y1, y2, y3, y4, and only you need to take dou y by dou zeta. Similarly, dou x by dou eta means, to this term you need to take derivative with respect to eta only. So for first two terms we need to take differentiation with respect to zeta, then next two terms we need to take differentiation with respect to eta. So in this way you can determine the dou x by dou zeta, dou y by dou zeta, dou x by dou eta and dou y by dou zeta. Okay. So simply you can write x is equal to summation of ni xi and y is equal to summation of ni y. So simply to find out dou x by dou zeta, we can write dou by dou zeta of ni into xi. Similarly, dou y by dou zeta, here x terms are constant because here we are taking only with respect to zeta. Similarly here dou ni by dou zeta y. And similarly these terms, for these terms dou ni by dou eta into xi, and for these terms dou ni by dou eta into y. So in this way you can get these 4 terms. So in general these 4 terms can be written as dou ni by dou zeta xi. Actually summation, here we are using this summation sign. Here summation sign should be there, okay, because these all are summation. Okay, all terms should be, it should include the summation sign, because here I varies from 1 to I is equal to 4. similarly you can write summation of I is equal to 1 to I is equal to 4 dou n I by dou zeta yi. Then third term is summation of I is equal to 1 to I is equal to 4 dou n I with respect to eta x, right? Finally last is summation of I is equal to 1 to I is equal to 4 dou n I by dou eta into y. So in this way you can write or you will get this Jacobian matrix J. Okay. And here this equation from equation first is nothing but dou by dou zeta dou by dou eta is equal to this J matrix dou by dou x dou by dou. Okay, so in this way you will get this Jacobian matrix as well as Jacobian matrix terms. Okay, here I have explained how to determine the Jacobian matrix terms. Now next what we are going to obtain is what we need our 4 terms. d dou u by dou x, dou u by dou y, similarly dou v by dou x and dou v by dou y. Okay, so we will get these 4 terms from this equation. Okay, so here I am concluding this lecture here only. Okay, because of the time limit. So in next lecture we will see how to find out or how to get these 4 values by using this first equation only. Okay, because our objective is what? To find out the strengths at any point within the isoparametric element. So to find out the strengths we need dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y. Okay, so how to determine these 4 terms by using these first equations we will see in our next lecture. So here I am concluding the lectures. In next lecture I will take one or two examples related to your Jacobian matrix also. After this derivation we will solve some examples. One example related to this Jacobian matrix. Okay, so here I am concluding this lecture here only. So thank you.